In this video, I'm going to prove that this second equation here is true by using induction. And to do this, we can check that for n equals 1, 2, 3, and so on, that the nth root of n factorial is indeed less than or equal to n plus 1 over 2. And to prove it by induction, I'm going to assume that this is true. So all I'll need to do next is show that it's true for n plus 1. Substitute it in anywhere you see an n value. Or in other words, that the n plus 1 root of n plus 1 factorial is less than or equal to n plus 1 over 2. And this problem is a fair amount trickier than the first one. And to prove this, we'll need to start with the left-hand side. What we can do to start this is to expand n plus 1 factorial. So we have the n plus 1 root of n plus 1 factorial, which we can write as n plus 1 times n minus 1 times n minus 2, and so on, all the way to 3 times 2 times 1. And if you're familiar with the geometric mean, you'll notice that this is exactly the geometric mean for the set of these n plus 1 terms here. And one idea that we can use involving the geometric and arithmetic means is that the geometric mean, which I'll just say GM, is always less than or equal to the arithmetic mean. And if you're unfamiliar with geometric mean, I'll do a little example here. So let's say we have a set of numbers, 2, 3, 4, and 5. If I were to find the geometric mean of this, I would just take the product of all of these numbers, so 2 times 3 times 4 times 5, and then take the fourth root of this, since we have 4 numbers in our set. So this would be the geometric mean of our set of numbers. And what I'm saying is that the geometric mean is always less than or equal to the arithmetic mean, which would just be the sum of these numbers divided by the amount of numbers, which is 4. And if you actually put these into calculators, you will see that this is indeed less than this. So we can apply this idea to our original problem here and say that the n plus 1 root of the product of this n plus 1 terms is always less than or equal to the arithmetic mean of these terms, which is just the sum of the terms, 1 plus 2 plus 3 plus all the way to n plus 1 divided by the number of terms, which is n plus 1. And now the right-hand side we can manipulate with some algebra. The formula for the sum of the first n terms is simply n times n plus 1 divided by 2. So we can apply this idea for this sum here, but for n plus 1 instead of n. So we would have n plus 1 times n plus 1 plus 1. So anywhere you see an n here, substitute it with n plus 1, and then divide this by 2. But notice we have n plus 1 in the denominator here, so I'll just put that in this denominator. And right away you can see that you can cancel out the n plus 1's, and what you're left with is n plus 1 divided by 2, which is what we were looking for. So in essence, we've shown that the n plus 1 root of the product of these n plus 1 terms, or n plus 1 factorial, is indeed less than or equal to n plus 1 over 2.